So hello everyone, my name is Dr. Griff. I'm a solution architect here at AllCloud. My main focus is on startups and ISV customers, both from Israel and EMEA. In this session, we'll cover the SaaS fundamentals. I know that some of the content might be a bit overlapping with the Thomas presentation a few minutes ago, but we'll try to make it interesting. We'll start with defining SaaS, and then we'll talk about what does it mean to be SaaS. We'll cover some of the most common models when talking about SaaS, and lastly, we'll talk about architecture patterns and the core concept of SaaS. So if you already started the recording, so we can go ahead and start the slides. If you guys have any questions or comments, you can leave them in the chat, and we'll review it later if we have time later. I believe we will have, right? So let's start with a quick review of some of the most common misconceptions about SaaS. So the first is that you're only doing SaaS if all your tenants are sharing the same infrastructure. While our solution might strive for this kind of setup to minimize management overhead and maximize cost savings, it's just not always possible to achieve this for every workload. So you don't have to share your infrastructure to run a multi-tenant SaaS business. Another thing here would be the automation. If all you do is automate the deployment for a customer, you're still not SaaS. There are a lot of other things you need to think about when coming to design a SaaS solution. It's just not only the operation here. Sometimes you'll hear people say that it doesn't matter what's under the hood, and the SaaS is only a marketing phrase. So it's really not only a marketing phrase, and we'll just discover everything related to the technical details of a true SaaS solution in this session, in the upcoming session tomorrow and next week. And lastly, maybe because SaaS sort of started here, but just having different databases for your customer doesn't make you SaaS. Well, it's a common way to partition multi-tenant data, but by no means it is the only way. And again, you should be thinking about all other things when designing your SaaS solution. So what is SaaS? So you can find a more concrete definition. I know that Thomas also talked about the definition of SaaS, but this is from, let's say, from the ISV perspective. The first thing to understand about SaaS is that it's not a technology, it's a business model, a mindset, as Thomas already said. This mindset enables you, the service provider, the ISV, to onboard, operate, analyze, and manage all tenants with a unified experience. Well, SaaS best practices rely on the acceleration and the efficiency of the onboarding and updating processes of your tenants, and of your centralized management of your tenants as well. And with SaaS, we try to avoid any one-off customizations. Ultimately, a successful SaaS architecture should enable the vendor to maximize its agility, innovate more often, grow to new markets and segments, and cut costs dramatically. You can think about it this way. The priority should start from the outside in. Right? You first have to operate the thing the right way, then you'll have to build your thing the right way, and lastly, you'll have to build the right thing. Meaning you should prioritize your operations and customer experience over features and functionality. This is what we call agility. So you must ensure that you're operating your service right, that you have the automation, observability, and management up and running, that you have support for customer onboarding, updates, and metering, that you have communication channel with your customer to have their feedback. Then you'll have to build your application right, meaning you have to apply those SaaS-specific concepts into your architecture. You have to apply tenant isolation, data partitioning, SaaS identity, and so on. We'll get back to that later in the following slides, but you should take a look at the application only later on. And then you should use the customer feedback and market research to build the best application and evolve as you grow to new segments. Once you have the operational agility, you can introduce any kind of feature seamlessly. So in general, when coming to provide a service, you should always prioritize your agility over functionality. That's what makes it SaaS. Now let's talk about agility. When talking about agility, we're talking about frictionless onboarding. You should design your SaaS solution to enable minimal friction on the onboarding process of a new tenant. The customer experience here is very important to your overall service. They expect the experience to be smooth. You have to think about frequent releases. You should build more frequently and release those changes much faster. The customer should get your updates without any patching, installing, or disruption at all. And service tiering as well. You should, if possible, offer multiple service tiers for your customers. That will make your customers and your business grow to multiple segments and markets, supporting different use cases and workloads. You should have better time to value. Meaning you should follow design principles and best practices and utilize the cloud by using managed services. All this to reduce your time to value with every new release. You can focus on development and provide your customer with the best application by doing so. And shorter cycles. An important aspect to keep you competitive is to know your customer, so you can design the best solution for them. This should be done by quicker cycles, better communication, and accurate targeting of your customers. Here you might introduce a new function to your business, customer success, so you can build better communication and relationship with your customers. And tenant customizations. You can and should, if possible, provide your customer with some customization that will help them feel more comfortable in your platform. This should not contain any custom feature or development effort that are too big to have a different setup. But things like cosmetic changes or modifications or some features that you can enable or disable ad hoc, this should be great and definitely should be part of your offering. Well, the business requirements will influence your architecture, and in the end, it will pave your way to the best solution for your customers. Now, what should it look like, actually? So you already see that, but we're talking about the SaaS blueprint. The blueprint is basically your North Star when designing your solution. So what does it mean to be SaaS? It's mostly about the blue boxes in this diagram that surround your application. Right? It's about the operation, lets you operate and onboard new tenants. It's about the SaaS identity. It's how you collect metrics and analytics for your tenants in a multi-tenant environment. It's how you connect your tenant to a billing and metering system, so you can provide a more accurate bill for the tenants. And even DevOps, it's not only your standard CI/CD pipelines anymore. There are very specific patterns you may need to follow to support multi-tenant solution. So it's really about the shell, the blue boxes around your application. The gray box inside, it is important, right? But you can put all kind of different systems and architecture inside and still call it SaaS because you have the fundamentals surrounding it. Of course, you should think carefully and design your application to allow tenant isolation and all the other core concept of SaaS. Now, let's talk a bit about what's not SaaS. So you already saw that as well, but this is very important to understand. For most of the MSP model, a provider will install and manage different environments for the customer. Each customer, each customer will have their own installation, right? And a customized version of your product. So the commonalities between the SaaS and the MSP is mostly the fact that you are managing the environment for your customer. But it's more than that, because in the end we have a lot of differences between the SaaS and the MSP, and it is the blue boxes as we just described them. All right, so some of them is the tenant, all the tenants should have the same version, and an update or fix should go to all of them when we deploy one, and the operation aspects should be with a unified experience for your side. mainly all those supporting services as we just described. And again, SaaS and MSP both are totally valid ways to run your business, but they're not the same, and you shouldn't really confuse one with another. In fact, you'll see sometimes that MSP is the first step before transitioning to a true SaaS solution. Now let's have another look here. Even if you do some consolidations and host multiple tenants in the same service, this might still not be a true SaaS. Right? So in order to be SaaS, you still have to introduce all those components we just discussed. Once you have those supporting services in place, and you have that single pane of glass for your onboarding on deployments, metrics, billings, and so on, this is where you're running a true SaaS application. Now let's talk about let's say the application itself inside a SaaS application. So we do some fine. We do have some, let's say, main models when talking about SaaS architecture. The first will be the silo model. That's the simplest model you can pick for your application. That basically means that your tenants are totally separated all the way from the front end through the back end to the data layer or any other related component as well. The second one is the pool model. Here you're basically sharing everything between your tenants. Nothing is tenant specific, and the isolation should occur inside the application. Well, as you might guess, this approach is much harder to develop, monitor, build, or operate in general. And then we have something in between, right? That's the bridge model. And it's just some kind of mix between the silo and the pool. This could use the same front-end layer with different backends, or the same backend with different data layer, or any other combination between the two across your entire application. The thing to understand here that is in every model, we have its own, let's say, pros and cons. And when designing your solution, you should think about your needs, your priorities, and trade-off in order to choose the model that fits you best in every layer of your application. So as you might guess, there isn't really a one-size-fits-all solution in SaaS, and you should build your own based on your needs. So let's find some of the, let's say, business realities. So we do find in some of our customers that they're running two different setups. The first will be a complete silo model for the premium tier customers, while the second will leverage the pool model for the lower tier customers. Well, of course, this setup might work for you only if you're offering those tiers in the first place. An important thing to mention here, this is not a bridge. We have two completely separated systems from different kind of customers. We do not share anything between those setup. They are completely separated from each other. So this is, let's say, one of the implementations that we see in reality. Let's review some of the, let's say, pros and cons. So hopefully this is pretty straightforward by now, but let's have it in a silo model, because all the infrastructure is absolutely isolated. This will be much easier with your compliance, okay? So you don't have to worry much about your compliance. You can have different customers with totally separated environment. You don't really need to care about cross-tenant impacts as a noisy neighbor, because your point of separation is at the infra level. And your blast radius is fairly low, because you don't share anything between those tenants in the first place. Well, some of the downsides, however, well, it can be pretty pricey to run those tenants separately, and your management deployment probably will be much more complex with a silo model. Right, for the pooled approach, you can see the opposite, right? Because everything is shared, you get better agility and cost. You'll probably have better centralized management and deployment system, but you do have some downsides here too. You will probably have more challenges with compliance running this model, and here you should basically accept some cross-tenant impacts, and should design a system to handle that. Also, your blast radius here is pretty huge, because you're sharing your infrastructure across your tenants, so if something goes wrong, it's going to affect everyone. So when you're designing your solution, you should be aware of those pros and cons and plan accordingly. Let's see a few examples of implementing those pros of those silo and pool models inside a real application. So you can start with a silo compute layer and the shared pool storage. You can go with a pooled compute layer as well and have both of them shared. And if you seek better data protection, you can stay with the pooled compute, but run your storage layer siloed. And eventually, if your architecture supports this, you can have both compute and storage pool, but have a different queues for each tenant. Those are your, let's say, silos. So as you can see, you can mix those models according to your needs. That's why we don't have a single solution, and it's important to understand your trade-offs with everything you choose. So it's also important to understand that at the end of the day, all the models will make you SaaS. They're sharing the same goals, and we already discussed that, but frictionless onboarding, you'll have that with both of the models, zero downtime deployments, unified proactive monitoring, SaaS identity and context, usage and consumptions metrics, and centralized billing. So now that we understand the common SaaS models, let's have a look at the key areas of the SaaS architecture. Now, one of the biggest things we see in multi-tenant environment is that the load varies. It's because new tenants are always coming, and the ways that the tenants are consuming your resources might be different, right? Some might run bulk operation, some might not, and we cannot really expect that. So simple scaling policy probably won't be enough here. So how do we align consumptions with activity when that activity can be really hard to predict, right? Another core part is the SaaS identity, right? So how do we bind the user to its relevant tenant? How do we flow that context throughout our system? How do we identify and authorize the user to its specific content? How do we make the process seamless to the developer with minimal implications? So you should get this part done pretty early because it's going to affect everything else. How you build your microservices, how you deal with data partitioning, or how you even implement isolation techniques. And third, we have to deal with the fact that the footprint of the data is going to be different between our tenants. So this is pretty much related to the first point, but specifically from the view of the data. Right, so how do you deal with storage bottlenecks? How do you minimize cross-tenant impacts at the data layer? Or how do you optimize your data costs? And lastly, how do you design a solution to be agile? Right, this is very important. So we have to think about how to make frequent deployments while limiting the blast radius. We have to design our metrics to be proactive so we know when there's a problem before our customers. And we need to know the health of our systems from the tenant perspective. Right? So those key areas are basically very crucial to your application. So let's take a look at the core concepts of the architecture itself. Now we can start with data partitioning. So data partitioning is basically how is the data organized and stored in the multi-tenant environment. But when we're talking about data partitioning, we aren't referring to tenant isolation, totally separated, two separated things. We're talking about how we are physically or logically storing the data for each tenant. For example, if using S3 as a data store, you can build different buckets per tenant, or you can utilize prefixes for that. If you go with tenant isolation, so how does your architecture ensure that one tenant cannot access the resources of another tenant? But this point is very crucial to your business. You must ensure that one tenant cannot get to another. For example, if you're using silo model, you can isolate your tenant with different accounts, different VPCs, or different subnets, right? Depends on your architecture. Or if you're using EKS, you could go with different namespaces per tenant or a completely different cluster. So the third thing is the SaaS identity. So how do we connect a user identity to its relevant tenant? And how do we flow that construct throughout our system? For example, here you can use, let's say, your SaaS context, you can insert it inside your JAW token if you're using a JAW token. So in that case, you can have the SaaS identity flow throughout your system. And onboarding, so how do we introduce new tenants to the system? What does it mean to register a new tenant? So you can basically utilize code suite, code build, code pipeline, all of these kind of services from AWS for running cloud formation stacks and deploying the relevant AWS services for each tenant. Given that you're using AWS managed services, and you can totally do that. And tiering, how do we offer different experience to tenant at different price points? Right? For example, if we have premium tier or regular tier or gold, silver, bronze, you name it. All right. So if you're using API gateway, for example, you can implement, you can leverage the API keys with usage plan for applying different settings for each tenant. Metering and billing, that's our last point here. But this is basically how can we measure a tenant's consumption and generate an accurate bill. Right? For example, if you're running on a silo model, you can probably tag your resources with a tenant ID. So you can later use your billing tools to aggregate all the tenant resources. Now, those core concepts are, of course, in addition to any other best practice you should follow. And those are relevant for any SaaS solution, right? No matter what model, application, service, or product, it doesn't matter. You have to apply those concepts to every layer of your system. Now, well, you can use AWS services for your solution, and you should, in order to have a better time to value. But you must know that even here, there isn't one solution. And every service might look very differently inside your architecture. So let's take, for example, DynamoDB. So the approach to multi-tenancy for DynamoDB is going to look very different from, let's say, OpenSearch or RDS. Same goes for messaging or the compute services or any other service you're using. So when designing your solution, each service needs to be addressed separately to support multi-tenancy. Let's have a quick overview on the operational aspects here. So you should treat your operations as part of your application, right? It's not just the application ops anymore that you have the NOC and you have to have, let's say, one backend for all or stuff like that. You have to design your operation to support multi-tenancy. You have to design your operation to support your SaaS solution. So you can have, let's say, more tenant-aware dashboards and understand better what's the status of each tenant. So you can have logs per tenant, and you can have a tenant context inside the logs and tenant context inside the metrics. You should also support tier-based deployment, right? If you can push update to all your tiers, silo, pooled, doesn't matter if you have premium tiers users or not. You should also have some advanced deployment mechanisms as well. You should be able to do dark launches, canary releases, A/B testing, and you should be able to roll back if something goes wrong. You should build this as soon as you can, and include every single component you're running inside a system into your operational dashboards, because in the end you'll have to have those tenant-aware dashboard in order to move with your business much faster and much, let's say, into another aspects and another markets. So let's have a quick reminder here. In SaaS, we're making the conscious decision to avoid any one-off deployments, and we will give up any initiative to close a sales deal that will result in one-off version of our service. So in that case, we can keep the efficiency and agility of running the same solution for all our customers, right? So taking that choice will enable us to grow our customers base even more and make up for that potentially lost deal. Now you can, however, support customization through feature flags or some kind of other fundamental service in your solution. That's okay, because in the end it will provide the same functionality for all your tenants, and you can turn it off or on for each individual tenant if needed. So let's sum it up, and I see that we already have some few minutes left for the questions, so it's a good thing. A few of the key takeaways here is that SaaS is a business model, right? It is a mindset in which your product is shipped as a service. Another thing is that not every service provider is a SaaS provider, and we already covered that with the MSP part. And you should probably promote agility and customer experience as top priorities. You should design each layer with a model that fits you best. And also you should design your system to support multi-tenancy by applying the SaaS core architecture concepts that we just discussed. You should also design your operational model to be tenant aware and support your business needs. And you should serve each tenant with the same experience and allow quick cycles. And in the end, there isn't really one-size-fits-all solution in SaaS, so you need to build your own based on your requirements. All right, so you can find here our office hours. So if you want to have a deep dive session with us, so we can have a discussion of your specific use case, please send your email to the mailbox, and someone will get back to you as soon as possible.